Question 16 says, if a cage containing a truck of coal weighing 750 is raised to a height of 90 meters in a minute, what is the total power expended? So now power is force times distance over time. And force times distance is mass times acceleration times d over t. So now our mass is 750. Acceleration is being given by gravity. Then distance is 90. T is 60 seconds. We're converting into seconds. 1 minute is 60 seconds. So now we're going to cross multiply. We're going to cancel out, which is giving us 11,250 watts. We're going to express this in kilowatts. It is 11.25 kilowatts. So now we look at question number 17. A man standing 2 meters from a charcoal fire is warmed mainly by what? By convection, radiation, refraction, and conduction. So now we are asked the method in which a man standing close to the fire is being warmed. We know that radiation is like invisible form of heat that warms the man up when he's staying close to a fire. Question 18. Cancerous cells can be destroyed by ultraviolet rays, alpha particles, X-rays, and infrared rays. So we know that cancerous cells can be destroyed using X-rays, which is used in radiographic centers for bones and X-rays. So number 19, when a pentavalent impurity is added to a pure semiconductor, it becomes a p-type, n-type, an insulator, an intrinsic semiconductor. So when a pentavalent element is an element which consists of 5 valence electrons in the outermost shell. When it's being added to a silicon atom consists of 4 electrons in its outermost shell. So now when this is being added, it takes 1, 2, 3, 4. So now it's being left with 1 extra. This 1 extra electron is being added, making it a negative. But if it's a tetravalent element, once you have only 3, it's being short of 1, making it a positive because you have more holes than electrons. For a negative, you have more electrons than holes. So that is the answer for question 19. And we're looking at question 20. A battery connection that permits current to flow across a P and N junction is called a reverse bias, forward bias, amplification, and rectification. So it's a forward bias. Forward bias simply meaning that a semiconductor, a P and N junction consists of a positively charged positive semiconductor and an N-type semiconductor, which is a negative semiconductor. So once the two are being connected, current flows from the P junction to the N junction. Once they say reverse bias means that it blocks current, and that is not the case for a P and N junction. So we're looking at question 21. Question 21. A car moves with initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? So we are going to find the acceleration. Acceleration is final velocity minus initial velocity over time. So from the question, we have 45 minus 25 divided by the time, which is 10 seconds. So 45 minus 25 is 20 over 10, which is equals to 2 seconds, 2 meters per second square. Number 22, a machine of velocity. Question 22, say we should find a machine of velocity ratio 6 requires an effort of 400 newton to raise a load of 800 newton through 1 meter. Find the efficiency of the machine. So now we are going to say efficiency equals to load over effort times 1 over GR times 100. From our equation, our load is 800, our effort is 400, and the velocity ratio is 1 over 6 times 100. So now we are going to simplify this. This goes out. This is going to be 2, and this is 3 over 50. So this 2 times 50 over 3 we translate to our efficiency. It's 100 over 3. Translate to 33.3%. So now we are going to be looking at question 23. The small droplet of water that forms on the grass in the early hours is called dew. It's not a hail, it's not a fog, it's a dew. We're looking at question 24. The wavelength of a wave traveling with a velocity of 420 meters per second is 42. What is this period? So we are going to solve for that. So the wavelength, we know the wavelength is, the formula for this is frequency, velocity is equal to frequency times lambda. So now we are going to find our frequency. Our frequency is V over lambda. So this is 420 over 42, which is equal to 10. So now frequency is equal to 1 over t. Frequency now is 1 over 10. It translates to 0.1. So the time is equal to 1 over 10, which translates to 0.1 seconds. So now we'll be looking at question 25. In a Faraday law of electrolysis, a graph is plotted of the mass deposited against the quantity of electricity is plotted. The slope of the graph gives what? The energy released, B, the electrochemical equivalent, the current flowing, and the charge released. So this is a graph of the mass, and this is the Q, which is equal to height. So now, let's say this is the graph relationship. So we are going to do change in M over change in IT is equals to the slope. So now, this slope is being represented as Z, and Z is the electrochemical equivalent. So this is Z root IT, which is equal to change in M. So this is the relationship for an electrolysis between the mass deposited and the quantity of electricity being used. So that is the answer for that. Is the electrochemical equivalent. The electrochemical equivalent is known as Z. Question 26. An object of mass 2 kg moves with a velocity v is equal to 10 meters per second with radius 4 meters. So now we are tasked to find the centripetal force. The centripetal force C, let's call it CF, is equal to mass times velocity squared divided by R. So now we are going to impute all our parameters into this. So this is 2 times 10 squared divided by 4. So this is 2 times 100 over 4. This is 50. So we're looking at question 27. High thermal capacity, high sensitivity, easy readability, accuracy over a wide range of temperature. From the statement above, the quality of a good thermometer are A, I, B, I, and I, C, I, and IV, D, I, and IV. So now we are being tasked to find the temperature, which of these qualities are the good properties of a thermometer. Okay. We have from in this question we have high thermal capacity, high sensitivity, easy readability, accuracy over a wide range of temperature. From the statement above, the qualities of a good thermometer are. So we are being tasked to find the qualities of a good thermometer. So we have the accuracy over a wide range, the high sensitivity, easy readability. So the answer will be likely to be D because we need a good thermometer to have high sensitivity, easy readability, and accuracy over a wide range. For question 28, which of these following electromagnetic waves has the highest frequency? So for the electromagnetic waves, we know that these are the common questions they ask. We know that the one with the highest wavelength is radio waves, and the one with the highest frequency is gamma. So take note of this. So the answer for this question is gamma rays. So we're looking at question 29. Say the capacitance of a parallel plate capacitor is 20 microfarads in air and 60 in the presence of a dielectric. What is the dielectric constant? So now the dielectric constant will represent it as D, and the formula is C. It's a ratio of the constant, the dielectric constant in air, and the dielectric constant in the presence of the dielectric. So this is 60 over 20, which is equal to 3. This does not have any SI units because this is just basically a ratio problem. So we're looking at question 30. The image below represents the position of a cone. The position can be described as, which of the position can be described as a neutral position? So we are tasked with finding the neutral position between these sets of shapes. Let me draw it out so you can see it. So this is this. So now, this is an unstable position because once you keep it like this inverted, it's going to fall off and go to a new position. So this is very unstable. This is a stable position and this is a neutral position because once this object rolls to another point, it goes to that new position and remains on that position. This is a neutral position. So that is the properties of a neutral position. It changes position. It changes position and remains at rest at that position. So this is a neutral position.
If you've been given any physics questions and you're stuck, maybe we solved something before and you didn't fully follow, no worries at all. Just drop the topic you're having issues with in the comments section. We'll treat that topic step by step, make it simple, and once we're done, we'll tackle past questions on it so you can master it properly. Don't keep quiet and struggle alone. Comment the topic now. And don't forget to like, subscribe, and follow for more.